Hey everybody, Mike here. We're going to take a look at chapter 3 today. This is graphs of linear equations. And we're going to start by reviewing the Cartesian coordinates, looking at plotting points, finding the coordinates of a point on the graph, and determining whether an ordered pair is a solution. We'll start with the Cartesian coordinates. It's two infinite number lines meeting at a right angle. The horizontal is the x, and this is the x-axis right here. The vertical is the y, and this is the y-axis. As we go to the right, x is positive and the values increase. As we go to the left, x is negative, the values decrease. Likewise for y, up is positive and down is negative. These two lines divide the infinite plane into 4 quadrants. The first is positive x, positive y. The second is negative x's and positive y's. The third is negative in both coordinates, while the fourth is positive in the x-coordinate and negative in the y-coordinate. If I want to plot a point like the point 4, 2, which is x equals 4, y equals 2, I can count 4 spaces for x, 1, 2, 3, 4, and that's this infinite vertical line. And then I'm going to count 2 for the y, 1, 2. Y equals 2 is this infinite horizontal line. And you can see these two lines intersect right here at the point 4, 2. Likewise, the entire plane would be covered by all of these infinite lines. Here's 4 points that we can look at. 1, 1, right here. Negative 2, negative 5 is down here. 3, 5 is here. And then 0, negative 2 is right here. Let's look at those plotted. So this would be 3, 5. This would be 2, negative 2, negative 5. X then Y is always the order. And we can see these three, 1, 2, 3. So that's negative 2, negative 5, 1, 1, and 3, 5 all lie on a line. 0, negative 2 does not lie on that line. And indeed, the equation of that line is y is equal to 2x minus 1. That tells us how to find y when we know x. If we were to plug points into the line, we would get, for 1, 1, 1 is equal to 2 times 1 minus 1, or 1 is equal to negative 2 minus 1, 1 is equal to 1. That's a true statement, which means that this point is on the line. For negative 2, negative 5, that's negative 5 is equal to 2 times negative 2 minus 1. That's negative 4 minus 1. That means negative 5 is equal to negative 5. Also a true statement. For 3, 5, we get 5 is equal to 2 times 3 minus 1. 5 is equal to 6 minus 1. 5 equals 5. And it's that point that wasn't on the line right here, 0, negative 2. Negative 2 is equal to 2 times 0 minus 1. Negative 2 is equal to 0 minus 1, but negative 2 is not equal to negative 1. The points that were on the line gave us a true statement, and it was this point that wasn't on the line that gave us a false statement. That means it's not a solution to the equation. Let's see if 0, negative 5 is a solution to 4x minus 2y equals 10. 4 times 0 minus 2 times negative 5 is 0, 4 times 0, plus 2 negatives make a positive, 0 plus 10, and 10 is equal to 10. So yes, it is a solution. What about 3, 1? Is that a solution of this line? 4 times 3 minus 2 times 1. That's 4 times 3, 12, minus 2 times 1, 2. 12 minus 2, that's 10. Yes, it is also a solution. Now let's graph this line. We can plot these 2 points, 0, negative 5, 0, negative 5, and 3, 1, 3, 1, and then connect them with a line, and we've graphed this line. What about -2, -9? Is that a solution? Well, -2 is right here, and -9 is right there. That looks like it's on the line. And indeed, 4 times -2 is -8, minus, let's see here, a -18, so that's a -8 plus 18 is 10. So yeah, it's a solution. Both visually, the line goes through it, and if you go back and you check it with the equation, both tell us it's a solution. A point like 4, -1 over here would not be a solution because it's not on the line. That's it for this section. See you next time for 3-2.